Today I would like to go over what we call sequences. What are sequences? Basically, sequences are a list of numbers that are generated by an algorithm. And by algorithm, I mean a rule. So let me give you an example of a sequence. It's a sequence that you are all very familiar with. List of positive integers. So 0, 1, 2, 3, 4, etc. Is there a rule that relates these numbers? And the rule is to get the next number from the previous number, you just need to add 1. So you add 1 to 0 to get 1. You add 1 to 1 to get 2. You add 1 to 2 to get 3, etc. And because, let me write the rule down here, you add 1 to the previous term. Because we know the rule, we can even generate the next term. So what would come after 4? Well, following this rule, we can just add 1 to 4 to get the next number. The next number is going to be 5. The next number after that is going to be 6, etc. So this is an example of a sequence. Now another example of a sequence is the list of odd numbers. So let's say I start with 1, I have a 3, I have a 5, I have a 7, etc. What will be the rule that relates these numbers here? Well, if you look at how we got 3 from a 1, we added 2 to the previous term to get 3. And again, we added 2 to the previous term here to get 5. And then again, we added 2 to 5 to get to 7. And because, again, we know the rule, add 2 to the previous term, we can generate the next term. What will be the next term after 7? You can just add 2 to 7, get 9, add 2 again to get 11, etc. So if you know the rule, then you can even generate the next term. And more than that, you can even generate what, say, the 10th term would be, or what the 100th term would be. So let me show you how to write out the rule. So it's easy to explain in words. For the first sequence here, you add 1 to the previous term. It's easy to put it in words, but you can't really use this definition when you're generating the nth term, or the 100th term, or the 1000th term. Same here, we can explain it in words, but the words are not going to really help us. We need a mathematical formula. And I think it's easier to show you than to explain to you why we need this. So let's say for our first sequence here, I'm just going to write the algorithm, and I'll explain what each of the terms mean in the algorithm. So for this term, or for this sequence here, the algorithm is going to be a sub n equals n minus 1. Okay, so what do we mean by a sub n? A sub n means the nth term. So for example, a sub 1 is the first term. A sub 1 would be this term here, right here, 0. It's the first term. A sub 2 would be the second term. A sub 3 would be the third term. Okay? So a sub n represents the term. N here is basically the same number as the n here. Let me use a different color to circle the n's. It's basically the same number as here. So for example, if we want to find what the 10th term of this sequence, our first sequence would be, the 10th term would be a sub 10. And that to get a sub 10, we will have to do 10, which is our n, minus 1. So that would be 9. So that means if we keep on going, 6, 7, 8, 9, this 9 in fact would be the 10th term. And you can count this to verify this. So this is our first term, second term, third term, 4, 5, 6, 7, 8, 9, 10. Okay, so the rule here, n minus 1. A sub n, to get the nth term, you can just do n minus 1 is our algorithm here in finding whichever term we would like. So we can even find the 1000th term. What would the 1000th term be? In this case, it would be a sub 1000, and that would be 1000 minus 1, which is going to be 999. So if we know the algorithm, we can basically find any of the terms that we would like. Now, this was a very easy sequence because the nth term, we started with 0, and that became our first term. So 1 became our second term, 2 became our third term. So we could kind of deduce, okay, so the number in the position is 1 less than its term position. So what I mean is the first term is going to be 1 less than that, 0. Second term will be 1 less than that, 1, etc. Okay, so this was a very easy sequence. So you might think, oh, we didn't really need this formula. We could just deduce that it's 1 less than the term number and just find our term from there. So maybe we didn't need an algorithm for this one. But for a more complicated sequence like this one, this is a sequence of odd numbers, it's very hard to deduce what is the 1000th term for this one. Okay, so let's try and find the 1000th term for this one. To get 1000th term, we should get, we should find the algorithm. Okay, so to find the algorithm, why don't you deduce what the algorithm would be? So a sub 1, the first term is a 1. The second term is a 3. Third term is a 5. The fourth term is a 7. So what is happening to each of these terms here? So how do we generate the next term? Let me write the algorithm here. So to find the nth term, what we're doing here is basically we're multiplying the n by 2, and then we're subtracting 1. Okay, so to get the first term, a sub 1, we are doing 1. Remember, our n is 1 here. So 2 times 1 minus 1, which is going to be 1. That matches with our first term here. To find the second term, we do 2 times 2 minus 1, which is 3. That matches with our second term here. To get the third term, we did 2 times 3 minus 1, which is 5. So as you can see, this algorithm works for all the terms in our sequence of odd numbers. And in fact, this algorithm is very famous, or you will see this a lot more often and later on mathematics in relation to odd numbers. Oops. Because if you multiply any integer by 2, it's an even number. And if you subtract 1, so this part is going to be even. If you subtract 1 from an even number, it's going to be an odd number. So this is a general formula for finding odd numbers. So now that we have the algorithm, we can now deduce what the 1000th term would be. So let's erase this part here for our workspace. So a sub 1000 is going to equal 2 times 1000, our n is 1000, minus 1. So that would be 2000 minus 1, which is going to be 1999. So because we know the algorithm, we can find our 1000th term here. Our 1000th term in this list of sequences is going to be 1999. So now let's look at a few examples to see how much we understand about sequences. So I'm going to write an algorithm. So let's say we have the algorithm a sub n equals 3n plus 2. What would be the first 5 terms of the sequence? First 5 terms. To get the first 5 terms, basically that means what is a sub 1, what is a sub 2, what is a sub 3, what is a sub 4, and what is a sub 5. And we can just use that algorithm to find the first 5 terms. The first term would be n is 1. Our n is 1. So we do 3 times 1 and then plus 2. And that would equal 3 times 1 is 3 plus 2 is 5. Similarly, we can do the same thing to a sub 2. This time n is 2. So we're doing times 2 instead of times 1, plus 2, and that gives us 8. 3 times 2 is 6, plus 2 is 8. N is 3, we do 3 times 3 plus 2, which is 11. N is 4, we do 3 times 4 plus 2, which is 14. N is 5, we do 3 times 5 plus 2, which is 17. So if we have the algorithm, you can find our first n terms of the sequence by just plugging in numbers 1 through n into the algorithm. Now, let's say we have the algorithm a sub n equals 7n squared. Okay? And let's say we want to find what is the 12th term of this sequence, a sub n. So in other words, what is a sub 12? Okay, so to get a sub 12, you can just simply plug in 12 in for n here. Okay, so we have 7 times 12 squared. That is going to be 7 times 144. And that is going to be 1008. Just make double check that is correct. 1008. Okay, so you can get the 12th term by just plugging in 12 as n. So in sequences, a sub n gives you the term. This is the term. And n is the, how should I explain this? N is the number assigned to the term, I guess. Assigned Okay, so the important thing is recognizing the algorithm and using the algorithm to find the terms of the sequence.